Yellowstone National Park, a geological wonder and home to one of the most powerful supervolcanoes on Earth, has once again surged into the spotlight. In recent weeks, an unsettling series of seismic tremors, ground deformations, and a dramatic rise in gas emissions have prompted geologists to issue a red alert for the region. This level of warning, rarely declared, indicates an imminent volcanic eruption or one already in progress. Yellowstone, resting atop a colossal magma chamber, has long been monitored by volcanologists due to its explosive past and potential to disrupt life far beyond its borders. But this latest warning signals a shift from academic concern to genuine emergency. Before we start, smash the like and subscribe buttons for more updates. The caldera, stretching over 30 miles wide, is the surface expression of a deep, dynamic, and unstable system. Over the past month, ground sensors have detected rapid uplift in multiple zones, particularly near the Norris Geyser Basin and Yellowstone Lake. At the same time, the frequency and intensity of earthquake swarms, small quakes that cluster together in time and space, have increased at an unprecedented pace. What began as minor tremors quickly escalated into thousands of detectable quakes, some registering over magnitude 4.0, shaking the forested landscape and alarming nearby communities. This spike in seismic activity, while not definitive proof of an eruption, has historically preceded major volcanic events around the world. In Yellowstone's case, the concern lies not only in the frequency of these quakes, but also in their vertical orientation. Many of the recent tremors indicate upward movement, suggesting that magma is rising through the crust. Combined with a sharp increase in the emission of sulfur dioxide and carbon dioxide, the evidence paints a sobering picture. Pressure is building beneath the park, and the Earth may soon vent its fury. Gas sensors stationed throughout the park have recorded levels of volcanic gases that far exceed normal baselines. These emissions are not merely noxious, they're a geological signature. Sulfur dioxide in particular is often a key indicator of magma nearing the surface. When molten rock ascends, it releases gases trapped under immense pressure. The spike in gas emissions is akin to a kettle hissing before it boils over. The intensity of these emissions has doubled in a matter of weeks, alarming experts who monitor such changes for early signs of eruptive behavior. Thermal imaging satellites have picked up anomalous heat signatures across various geothermal regions. Certain geysers and hot springs have become erratic or ceased functioning altogether, clear signs that underground plumbing systems are being disrupted. As magma rises, it can boil groundwater, alter pressure zones, and completely reshape hydrothermal features. Some geysers have erupted out of their usual cycles, spewing steam and debris in unexpected bursts, sometimes with more force than has been recorded in decades. The red alert issued by geologists is not a decision made lightly. It reflects a convergence of data that collectively points toward a destabilized magma chamber. While Yellowstone has had eruptive episodes in the past that were relatively small, the real fear is that this may not be a minor event. The supervolcano has a history of producing massive eruptions, each capable of reshaping landscapes and influencing global climates. The most infamous eruption occurred approximately 640,000 years ago and left behind a caldera large enough to be visible from space. That eruption ejected over 1,000 cubic kilometers of material, blanketing much of North America in volcanic ash. The current concern is not merely about ashfall or local lava flows. If Yellowstone were to erupt on a supervolcanic scale, the implications would be continental, even global. Volcanologists are particularly worried about the sheer volume of ejecta that could be released. Ash clouds could ascend into the stratosphere, where high-altitude winds would disperse them across vast areas. Within days, sunlight could be dimmed, temperatures would begin to drop, and crop failures could begin in areas far from the blast zone. A volcanic winter scenario, though still hypothetical, becomes frighteningly plausible under these conditions. Air travel would be among the first systems affected. Volcanic ash is deadly to jet engines, and the spread of ash plumes across North America could ground flights indefinitely. The shutdown of airspace would ripple across global supply chains, stalling commerce and isolating regions that rely on imports for food, medicine, and technology. Electrical grids could also come under strain, particularly if ashfall damages transformers and blocks cooling systems. Even solar panels could lose efficiency due to the thick, dark layers of ash settling across infrastructure. Closer to the eruption, the devastation would be near total. The blast zone could encompass hundreds of square miles, incinerating forests, lakes, wildlife, and entire towns in seconds. Pyroclastic flows, superheated clouds of gas, ash, and rock, could travel at speeds exceeding 300 miles per hour, erasing anything in their path. For those within the immediate vicinity, escape would be nearly impossible once the eruption began. Emergency services, already on high alert, have begun mobilizing, but the scale of evacuation required would dwarf anything previously attempted in the US. The Red Alert has prompted scientific institutions around the world to focus their resources on Yellowstone. Seismometers are being recalibrated, new sensors installed, and satellite networks adjusted to give maximum coverage of the caldera. The world is watching, not out of academic interest, but out of necessity. A Yellowstone eruption isn't just a national emergency, it's a planetary concern. The lessons learned from past eruptions such as Mount Pinatubo and Geological serve as stark reminders of how even modest volcanic events can disrupt modern life on an epic scale. Yellowstone, with its massive magma reserves and volatile history, stands in a class of its own. Wildlife behavior in the park has also begun to shift. Bison have been observed migrating in unusual patterns, and some species of birds have taken flight well outside their normal nesting periods. While animal movements are not definitive predictors of geological events, they often reflect subtle environmental changes that humans cannot perceive. Increased ground temperature, vibrations, and gas concentrations can all be sensed by animals long before equipment registers an alert. In the surrounding towns of Wyoming, Montana, and Idaho, the atmosphere is tense. Shelves in stores are being emptied, and residents are grappling with whether to leave or wait. The uncertainty is exacerbated by the volatile nature of supervolcanoes. Even with today's advanced tools, predicting the exact timing and scale of an eruption remains elusive. Some are preparing for the worst, converting basements into makeshift shelters, stockpiling food and water, and setting up emergency communication systems. Others are choosing to evacuate entirely, unwilling to risk becoming statistics in what could be the most significant geological event of the century. Geologists monitoring the situation have maintained a round-the-clock presence at the park. Data streams are analyzed in real time and decisions are being made hour by hour. Despite the intensity of the warning, no one knows if this will be a cataclysmic release or a slow, prolonged eruption that vents gas and lava over months. The ambiguity only deepens public anxiety. For many, the mental strain of living under the shadow of potential eruption is nearly as heavy as the physical threat itself. The Yellowstone magma chamber, estimated to contain thousands of cubic kilometers of molten rock, is not a uniform body. It contains layers, voids, and semi-solid structures, all interacting in chaotic, often unpredictable ways. As magma rises, it must force its way through kilometers of brittle crust. Along the way, it can stall, fracture rocks, or even find new pathways to the surface. This makes forecasting exceedingly difficult. A red alert doesn't mean a blast is guaranteed, but it does mean all signs point to a significant escalation. Another complicating factor is the hydrothermal system above the magma chamber. As the pressurized magma interacts with underground water, explosive steam-driven eruptions, known as phreatic eruptions, could occur even without a full volcanic outburst. These smaller, localized explosions have the potential to throw debris and boiling water hundreds of feet into the air, endangering visitors and park personnel. These secondary events can sometimes precede larger eruptions, acting as early warnings that pressure is nearing a critical point. Despite their preparations, scientists acknowledge the limitations of their models. The Yellowstone system has erupted 3 times in the last 2.1 million years, and each event was preceded by a unique sequence of geological signals. No single pattern has emerged to act as a definitive countdown. This uncertainty makes the red alert all the more daunting. It's a declaration of heightened risk, a call to readiness, but not a guarantee of immediate action. And yet the pressure is building and time is growing short. Within the scientific community, debates rage over what constitutes an acceptable threshold for evacuation. Some argue that waiting for visible signs, such as ground cracking or volcanic lightning, is too late. Others caution against mass panic, noting that Yellowstone has experienced significant activity before without erupting. But this time, the convergence of data suggests a tipping point. The weight of historical precedent, combined with modern measurements, implies that something extraordinary is occurring beneath the surface. What makes Yellowstone particularly dangerous is the possibility of multiple eruption styles occurring simultaneously. A supervolcano like Yellowstone can erupt in a variety of ways: lava flows, ash column collapses, hydrothermal blasts, all within a single event. The complexity of its geological plumbing means that no two eruptions would look the same. The park could experience venting in one area while catastrophic explosions take place miles away. This unpredictability adds another layer of urgency to the red alert. If the eruption does occur, even in a moderate form, the social and economic fallout would be immediate. Agriculture across the Midwest could suffer from ash contamination. Water supplies might become toxic. Hospitals could be overwhelmed with respiratory cases as ash blankets entire cities. In such a scenario, emergency infrastructure would be pushed to the brink. Government agencies have contingency plans, but none have ever been tested on the scale a full Yellowstone eruption would demand. Internationally, the event would send shockwaves through financial markets and trade systems. Countries dependent on U.S. agricultural exports might face food shortages. Climate models would need to be recalibrated to account for the cooling effect of volcanic aerosols. In the worst-case scenario, global temperatures could fall by several degrees, leading to shortened growing seasons and a spike in food prices worldwide. The natural beauty of Yellowstone belies the immense power sleeping beneath its surface. Now that power stirs. With each passing day of seismic rumbling and gas emissions, the possibility grows that the Earth may soon remind humanity of its raw, untamed force. The red alert stands not just as a technical classification, but as a warning to the world. Something ancient and immense is awakening beneath the surface of America's first national park. As the red alert status intensifies, efforts to understand the evolving situation at Yellowstone have moved beyond regional assessments. International collaboration is accelerating. Volcanologists from Iceland, Indonesia, Italy, and Japan, regions with extensive volcanic histories, are pooling their data, comparing Yellowstone's current behavior with past eruptions in other parts of the world. Satellites operated by the European Space Agency and NASA are being redirected to provide higher-resolution scans of the caldera, capturing changes in topography, heat flux, and gas composition in near real time. This represents one of the largest global monitoring initiatives ever undertaken for a single volcano. Amid this surge in international focus, new models are being developed to simulate possible eruption scenarios. Using machine learning, geophysicists are feeding Yellowstone's real-time telemetry into predictive systems capable of running millions of eruption sequences per day. The goal is to anticipate not just the likelihood of an eruption, but the style, intensity, and most likely geographic path of the event. These simulations suggest several possibilities, ranging from a limited rhyolitic dome extrusion to a full caldera-forming explosion. The worst-case projections extend ash coverage across the entire United States, reaching as far as Europe in jet stream currents within 2 weeks. One of the most troubling revelations from these simulations is the possibility of multiple eruption phases. Initial blasts could clear a path through the crust, followed by sustained eruptions lasting weeks or even months. This differs dramatically from the sudden, singular blasts more commonly associated with stratovolcanoes. In Yellowstone's case, the danger lies not just in one cataclysmic event, but in the prolonged instability it might unleash. The eruption could wax and wane, producing powerful aftershocks, recurring lava flows, and continuous ash emissions, stretching emergency response capabilities far beyond their limits. Infrastructure near the park is already under visible strain. Roads have begun to buckle in places where geothermal heat has warped the asphalt. Geysers and fumaroles near these areas are venting more frequently, with some emitting a deafening roar not previously recorded. Park rangers and geological field teams have withdrawn from the most volatile zones, abandoning monitoring equipment rather than risking personnel. Despite these precautions, a few remote sensors have captured what appear to be harmonic tremors, vibrations typically associated with magma moving through underground conduits, often a precursor to eruption. Beyond the technical and geological implications, the psychological toll is growing. Local populations, already contending with the stress of a potential disaster, face a media frenzy and constant sirens of incoming alerts. Rumors and misinformation circulate rapidly through social media, often exaggerating timelines or suggesting conspiracy-level government cover-ups. This digital noise has made communication more difficult for scientists trying to keep the public accurately informed. Several emergency broadcasts have had to clarify false evacuation orders or debunk viral videos claiming to show lava breaching the ground surface. With communications channels at risk, ham radio networks and satellite phone relays are being prepared as backups. FEMA has begun pre-positioning aid supplies, ventilator units, clean water kits, and mobile medical tents in cities like Bozeman, Billings, and Casper. Meanwhile, military transport units have been placed on standby to assist with mass evacuations should the situation deteriorate further. These preparations are unprecedented for a domestic natural threat of this scale and reflect just how seriously the red alert is being taken. Urban planners and disaster preparedness experts are racing to draw up evacuation protocols. Unlike hurricanes or wildfires, which can be monitored and adjusted for route shifts, a supervolcano eruption could render large areas uninhabitable in hours. In anticipation, modular refugee zones are being plotted out using school gymnasiums, fairgrounds, and sports arenas to house displaced citizens. Emergency drills are being rehearsed, and the National Guard has begun distributing protective breathing masks and goggles to communities on the edge of the projected ashfall zones. The economic implications are already being felt. Insurance markets are tightening across the region, with some providers freezing new policies entirely. Energy companies are reassessing the risks posed to power lines, hydroelectric stations, and fuel storage depots that lie in potential blast or ashfall zones. Meanwhile, agriculture is bracing for disaster. Late summer is a crucial harvesting period, and fields across Montana, Idaho, and northern Wyoming may soon be choked with volcanic ash, which renders soil infertile, contaminates irrigation systems, and poisons livestock feed. Banking and finance are not immune. Commodity prices, especially for grain and livestock, have surged on speculation of agricultural collapse. Transportation and logistics firms are modeling disruptions to road and rail networks across the western United States. Ash can disable train engines, jam truck air filters, and turn even well-paved highways into slick, powder-covered hazards. The prospect of Yellowstone erupting is no longer seen as a remote possibility. It is now a live risk, reshaping economic forecasts and contingency strategies on a national scale. From a scientific standpoint, what's happening beneath Yellowstone offers a unique but terrifying opportunity. The red alert has triggered the activation of deep borehole cameras, devices that can withstand high heat and pressure while sending back live imagery from within fault lines and magma conduits. Preliminary footage has revealed glowing rock fractures pulsating with red-orange light, expanding visibly under pressure. These observations are among the most direct ever captured of an impending magmatic event and are being scrutinized frame by frame for signs of acceleration. Glaciologists, too, are becoming involved. The Yellowstone region, while not a glaciated zone, does influence and intersect several freshwater systems sourced from nearby mountainous snowpack. If heat surges suddenly, these snowpacks could melt en masse, leading to rapid flooding downstream. The interaction of magma, snowmelt, and river systems could result in highly destructive lahar flows, volcanic mudslides capable of erasing river valleys and flooding plains hundreds of miles away from the eruption's epicenter. Air quality experts are analyzing potential dispersion models to predict particulate distribution. In the event of a full-scale eruption, air filtration systems in residential and commercial buildings may not be able to cope. Fine ash can infiltrate homes, offices, and hospitals, causing respiratory issues, eye injuries, and long-term lung damage. The smallest particles can remain suspended in the atmosphere for years, leading to persistent haze, disrupted weather patterns, and elevated cases of asthma and bronchitis. Educational systems are beginning to respond as well. Schools across several states are preparing for indefinite closures. Some districts are rolling out emergency homeschooling programs, relying on digital platforms that may still function in ash-free zones. Universities with volcanology departments are shifting coursework toward real-time analysis, encouraging students to help analyze data, build models, and contribute to the international effort. For many young scientists, this is their first experience working through a potential supervolcano event in real time, an experience that will shape careers and academic disciplines for decades to come. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on Yellowstone's red alert? Eruption likely or not? We want to hear from you. Thank you for watching and see you next time.